Hi guys, I'm Shaylee. Today I'm gonna go over trigonomic ratios and we're just gonna discuss the importance of them. We're gonna go through some example questions and I'm gonna apply it to some real world examples and then some common mistakes that people make. So first off, the trigonomic ratios. Here I have the triangle, here's theta. And this is a right triangle. So across from the right triangle angle is the hypotenuse. And then there's the adjacent and the opposite. So, you guys have all probably heard of sine, cosine, and tangent. Sine is basically the opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, so also one way to remember that is SOHCAHTOA. So sine opposite over hypotenuse, cosine opposite over that was weird, sorry. Not opposite, adjacent over hypotenuse. And then TOA, tangent is the opposite over the adjacent. Okay, so that's what our little triangle looks like. Just to give you a visual representation. Um, One example I like to think of in the real world, um, think of a fire truck ladder. We need, if we know how long the ladder is and the angle it's going at, we can predict how far up the building it's gonna go and like how high it will reach on the building. Anyways, that's a little thing I like to think of, but yeah. Okay, first example I wanted to do is so if we have a right triangle where the hypotenuse is 10 and it has a 30-degree angle, um, find the opposite. So we would use sine because we are dealing with, um, sorry, it's so hard to read this while showing you guys. We are going to use sine because it's dealing with opposite over hypotenuse, and we went over that over here. So we are going to take the opposite, um, and which we don't know, we're trying to find the opposite and divide it by the hypotenuse, which is 10. I drew a little triangle over here, and then the angle is the 30 degrees. So do sine 30 degrees equals x over 10, and then this is basic algebra, but we multiply by 10 on both sides, and then we plug it into our calculator. We get 0.5 times 10, and then it equals 5, so x equals 5. That's how we would solve for that. Okay, example number 2. So a 15-foot ladder leans against a wall. The base of the ladder is 9 feet away from the wall. What is the angle the ladder makes with the ground? So here's a little triangle I drew. So this is the ladder. It's 9 feet. This is the wall. It's 9 feet away from the wall. The ladder is 15 feet. And we're trying to find what is this angle, theta. Okay, so we would use cosine because we are dealing with adjacent over the hypotenuse. And we'd actually use inverse cosine because it is an angle we are trying to find. So do cosine of theta equals 9 over 15th. And then we can put cosine or the inverse of cosine over on this side and do theta equals inverse of cosine over 9/15. And then I just plug this into my calculator and I got theta equals 53.1. So there's two examples. I hope that made it really easy for you to follow. Um, but I also just wanted to go over some mistakes that students make, some common mistakes. Sometimes they make a lot of mistakes putting it into their calculator. I had to practice and learn how to put it into mine. And you have to make sure it's in radians instead of degrees. So just check your settings on your calculator. And then I feel like students will sometimes mix up like where the opposite, where hypotenuse and where adjacent is. So hypotenuse is always going to be the one across from the 90-degree angle. Um, that's how I always remember it. But yeah, hypotenuse is always constant. It never changes. It's always across the 90 degrees. And then sometimes students will mix up opposite and adjacent. And just remember that adjacent is one of the two lines that actually forms the angle you're talking about. Um, but yeah, once you master, I think the biggest takeaway is to remember SOHCAHTOA helps you remember um, sine, cosine, and tangent and how you can solve them. Um, yeah, thank you for listening, and I appreciate you being here.